Welcome. This is 1.2.6, maximizing your motor's power. This is going to be a very short and quick introduction of what you guys are going to do in class. First off, we got to talk about some terminologies. The omega naught. Omega stands for the omega naught, which is this symbol right here, stands for no load speed. What that means is you connect your motor to the power source without anything on it, and it's just how fast can it turn. Tau, which is this symbol, stall, or torque, stall, means that this is you pinching the motor and stopping it from moving. It will not move any further. Now, if we put the speed versus torque on a graph here, then you're going to notice that as torque is at 0, there's nothing on it, it has a maximum speed. But if you have 0 speed and 100% torque, that means that you are stalled. It's not moving anymore. And then this is the half speed. So this is the equation of this line, and what we can do is use that equation. Now, depending on the voltages, it changes where that line is. So we can look here and we can see the different speeds at different voltages. Now, power is just torque times omega, or torque times omega, the angular speed. So, why is there no power here? Because the amount of power here is because there's 0 times whatever this free speed, or 0 omega times whatever this torque is. So the best place is the halfway. Why do you think that is? It's because this has as much speed and as much torque as possible, and so we call this the half torque. So here's the linear equation on the last slide, and we multiply both sides by the torque to produce this equation. Now we're going to redistribute this torque throughout the equation, and we get this. Now this is a negative parabola, so it's going to be doing a downward facing parabola, and this is the parabola that you get. This is the maximum power, where you maximize the amount of power for that particular torque. So this is where you had no load. That was your omega naught. This is your tau stall, and here's your half. This is max power. So this is what you guys are going to do. Step 1, you are going to create a motor and stall it. And you're going to figure out how much force times its distance is it to stall your motor at a given voltage. So then you're going to then figure out what the same motor as the last one being used to power this drum for a radius of 2 inches, lifting at 2 pounds. What is the torque? Well, it's this times that. So 0.2 pounds times the 2 inches. Instead of the direct driven, what gear ratio would make that deliver the best power? Well, we can look at it and the torque out versus torque in, and we can actually figure out the best gear ratio because of that. And then we can set up a gear system that is fairly close, a 12 to 60 gear system, which gives us 0.19, and that gives us the best optimized gear ratio. Now, why would you want to change your gears on a bike to help you win a race? This optimizes the power that you put into it and helps you optimize the best amount of power your legs pump into the bike, so that you're using every ounce of those power and every watt to help you win that race. And if you have any further questions, ask your teacher.